All right, so in these last few slides, I'm introducing you to two different types of ANOVA tests. There's a one-way ANOVA and a two-way ANOVA. I'm going to be asking you to work with one-way ANOVA within SPSS. However, I will not be asking you to work with two-way ANOVA within SPSS. I still want to give you the content for understanding the benefits of a two-way ANOVA test, but we won't be moving this into SPSS. So keep that in mind. So I want to give a little bit of background to assumptions. And we were actually introduced to assumptions in t-tests when talking about Levene's test for significance. And so an assumption in statistics, they serve as rules that must be true for a statistical test to work properly and give you trustworthy results. In Levene's test for homogeneity of variances, we're checking if the variances of scores is roughly the same across all groups. If it is roughly the same, that's actually a good thing for us. We want to see that. If they're not the same, there may be other tests that are more appropriate for our data. We're not going into what other tests are available. That's not the scope of this class, but I do want you to understand what's happening with these assumptions. There's also an assumption of normality, which checks if the data for a group would form a normal distribution. This is another test that we would hope to be true. Again, if it's not necessarily true, we might want to use other tests to perform our analysis. But again, outside of the scope of this class, just for here, I want you to understand that these assumptions are being made with the data that we are using. So if both conditions are met, you can be more confident in your results. If they're not met, it doesn't mean that you can't run an analysis. Again, we would just have to make some modifications. So with the one-way ANOVA, is used to determine whether there are statistically significant differences between the means of three or more independent groups. It examines the effect of a single independent variable, which we actually refer to as a factor, on a continuous dependent variable. Its key characteristics include that it tests one independent variable with three or more levels or groups. It uses one continuous dependent variable. The null hypothesis is that all group means are equal, and the alternative or the research hypothesis is that at least one group mean differs from the others. An example of this would be testing whether GPA differs among 7 racial groups. And I'm making this reference because when I produce the video for SPS, using SPSS to run our ANOVA, I'm going to be referencing this specific research scenario. Let's say we do run that test, we get the results. How do we write them into our APA format? This that you see here in this slide is exactly what I would want you to write. Make it contextually appropriate, but use this as an outline. If you copy and pasted this into an assignment that I'm asking you to complete and making sure that you modified the context and the numbers to reflect the test that you ran, you're good to go. That's exactly what I want to see. You're welcome to get a little bit more creative in the wording if you feel inclined, but I'm trying to make this one a little bit more straightforward because there's actually a lot more involved in reporting the results of a one-way ANOVA, particularly because we incorporate the post hoc test. So I'm going to read the results here. I'm going to point out where it is that we are going to insert the information that we have, and then we'll in a later video when I show you the SPSS results, it'll make a little bit more sense. So you would write that a one-way ANOVA was conducted to examine differences in GPA across racial groups, including Asian, Black and African American, Chicanx, Latinx. I wrote etc. here because I'm trying to keep this contained to just this one slide, but you would include the names of each of the groups that you're referencing, right? So if we were to incorporate all of the groups as part of this analysis, then I want to make sure I'm including Native American, Pacific Islander, white, and other students. But like I said, I'm just trying to keep it condensed to keep it on one slide. Results revealed a significant difference in anxiety scores across education levels. F, so this is where we're kind of seeing that that formula for how you want to report your results. F of 7 and 883. So those are your degrees of freedom between and within groups. This 15.98 is your F statistic. And then this P is the significance reported from SPSS. And so we'll see all these things pop up when we move to the SPSS piece. Because we found significance in this test, we would also want to make sure we report the post hoc results. If this test did not show significance, then the way that we frame our post hoc test results would be a little bit different. You would still reference that you ran a post hoc, but you would, kind of emphasize that there were no significant differences among the groups that you were comparing. So in this particular case, because we found significance, we would write post hoc comparisons using the 2-key HSD test indicated that Asian students with a mean of 3.47, standard deviation 0.48, had significantly higher GPA than Black and African American students. I apologize, I should have put a space here, but reporting their mean, standard deviation, their significance level. Chicanic students, mean, standard deviation, significance level, and Latinx students, mean, standard deviation, significance level. That concludes where in the test you're going to see significance. This second half of the paragraph here is now identifying where we did not find significance. So Asian students did not differ significantly from Native American students, P of 0.88, Pacific Islander students, P of 0.39, white students, P of 0.58, or other students, P of 0.98. I put an ellipses here to indicate that you would do this for however many points of significance you find in your analysis. So I'm stopping here because, again, trying to keep it condensed, but make sure that you are reporting every single area that you are finding significance. As part of completing your SPSS assignment associated with this module, you are going to paste the results of your post hoc test into your document that you submit to me, which means I want you to make sure that wherever you're finding significance in your results, you are reporting that to me. Okay, so please, please, please be very careful, be very thorough, and always let me know if you have questions. All right, so a little bit of background on the two-way ANOVA. The two-way ANOVA examines the influence of two different independent variables on one continuous dependent variable. It allows you to test for the main effect of the first independent variable, the main effect of the second independent variable, and then the interaction effect between the two variables. So its key characteristics include that there are two independent variables, each with one or more levels, and one continuous dependent variable. It can detect interaction effects when the effect of one independent variable depends on the level of another. An example might be testing how sex, male and female, and father's education level, high school, undergraduate, graduate, affect GPA, including whether the effect of education level on GPA differs between men and women. So it's a very complex and a very powerful way to use ANOVA. Again, within the context of this class, we're not going to use or ask SPSS to do a two-way ANOVA for us, but I wanted to introduce you to this nonetheless. Okay, so that's all I've got for this presentation. This is all centered on ANOVA. ANOVA, learning about the post hoc test, and also understanding how to report the results for a one-way ANOVA, and a little bit of context for how two-way ANOVA is used. As you move forward, if you have any questions, please make sure you let me know.